Okay, so for part B, we are still finding all of the zeros. Okay, and we are gonna write ourselves a little note because this one is special. So when we do step 1, the P over the Q, okay, when you have 0, yeah, you have plus or minus 0, but you also have all of the real numbers. And then over plus or minus 1. So we're going to make ourselves a little note. If the constant is 0, okay, if the constant is 0, and all real numbers are possible zeros. I should say integers. Okay, so it's all the set of real numbers that are possible zeros, that are rational, that are integers. And thus we are going to rely on the graph. So thus, using the graph, I'm going to say we must use the graph to locate the rational zeros. Okay, so we have to do that with the graph. Okay, so we're going to type this into our y equals, we have x equals 4 minus 13x cubed plus 55x squared minus 91x. Okay, so type that in with me. And if you want to go back to your z standard, okay, we can graph that. Okay, and to me there's one that stands out right away. Did you guys find it? Yeah, what is it? Which one is pretty clear to see on this? Okay, maybe we're not sure. Okay, yeah, 7, right? And if we're not really sure, remember we talked yesterday about another place you could go? Where else could you go? Yeah, you could go to the table. Yes. And you can also use the zero function that we used on Monday. Okay? I like the table because it's quicker. When you're looking at the table, what are you looking for? Yeah, zeros in the y. Okay, so, oh look, at 7 there's a 0. Let's see if there's anywhere else. Oh, where else? Yeah, at 0. And that one's hard to see on mine. So if you have one of the colored ones, that's what I think makes it so cool. Well, I guess you can't see this well on the camera. But if you have one of these, you can clearly see the blue line goes through 0, whereas mine is going to be harder to identify because it's right there. It's right on there. You could also zoom in, okay? But like I said, the table's a good option. So we have 0 and we have 7. Yay! Okay, so now that brings us to what's our next step? Synthetic division. So for synthetic division, again, I just want to stress it does not matter which one you do first. Okay? The synthetic division is really doing a few things for us. And try to stay with me with this one because I'm going to show you another way to write this out, which I think is cool, that I think you will like. So you have 1, negative 13, 55, negative 91, and don't forget even for that constant term, you have to have a placeholder. Okay, so you have to have that 0 at the end, okay? Will you guys check that for me? If you're working ahead, just check that real quick, please. And again, you can choose, it doesn't matter if you start with 0 or 7, okay? I just usually start with the first one numerically. And then this one's going to be a fun one to fill in, because anything times 0 is 0, so that you're just adding straight down, and then when you multiply, you get 0. Then you're adding straight down. When you multiply, you get 0. Negative 91. So see, if you didn't put that 0 there, you would have this isn't a remainder. That you would have a remainder. And then if you multiply here, yay, we get 0. So we did this to verify that 0 is a 0, which sounds very meta. 0 is a root, right? But the real reason why we're doing this is to find the zeros that aren't on the graph. Because what zeros can't we find from the graph? Imaginary. What are other ones that we can't find exactly? The decimals that are really what? Remember we did a couple yesterday? The radicals, so the irrational numbers. Yeah? Okay, so now we're going to do this again. Yesterday what we did is we wrote the whole thing out again. I'm going to show you how you can just connect them together. So remember how you use these as your new coefficients? What you can do is just set up another synthetic division right here. I like that reaction. It looked more wild than frightened. I hope I read it right. Okay, so yeah, what you can do is you can just loop it on here, right? So that'll take up less space for you. And the reason why I am doing it again is because this function, this is a number, an x squared, and an x cubed. Okay, and it's a cubic function, and I don't want to try to factor it because I have like the 13, 55, and 91. I don't see any common factors there. Okay, so I want to go till I get a quadratic, because if I have a quadratic, what can I use? You can always use what to solve the quadratic? Yeah, you can always use the formula, right? Okay, so it's a sure way to get what you need. Okay, and then you're going to subtract. 13 times 7 is 91. Yay! This is our remainder, and now we have a quadratic. Okay, now, we just talked about the quadratic formula. That is the way that you're going to want to go. Because think about the graph that you just saw. Did you see any more whole numbers besides the 0 and the 7? No. Did you even see any decimals on there? Any that weren't like a rational number? Nope, those are the only two that we saw, which means the other two zeros are probably what? They're probably imaginary, right? Because we didn't see them on the graph. The other case would be, oh, they were a lot larger than my window, right? Okay, so we set the quadratic equal to 0, and then we're going to use the quadratic formula. So I'm going to let you do that. I want you to simplify using the quadratic formula. Okay, so you can use this space here. You have your A, your B, your C. Once you do it, you can write down all your final zeros when you're ready, okay? How are we doing at remembering the formula? Opposite of b, plus or minus b squared minus 4ac. Okay, so it's always minus the 4ac, but the symbols of the a and the c are going to determine whether you subtract or if you add. So did you have to subtract or add for this one? Subtract. So you should have 36 minus, because it's a negative 4 times 1, which is negative 4. Negative 4 times 13 is 52. And then when you subtract 36 minus 52, what do you get? Negative 16. Okay, so thumbs up if you got that under the radical, the negative 16. Okay. All right, so now we simplify. What's the square root of negative 16? 4i. All right, awesome. So this is going to be 6 plus or minus 4i. And then remember, you're dividing each of these by 2. So this is where you're going to simplify. So you have 3 minus, yeah, how do we do? Okay, and then we're going to list out our zeros. Okay, so the zeros, don't forget, 0. And then here, 7 is a 0. Right, once we confirm that, 0, 7. And then we have 3 plus 2i, 3 minus 2i. And then we just want to check to make sure the number of zeros matches the degree. So 4, 4, life is good. All right, I'm going to have you guys try part C. So we have x cubed minus 2x squared minus 2x minus 3 equals 0. And when you do the first step, the p over q, if you notice that the q is just a 1, okay, if you divide anything by 1, you're just going to get itself. So if you want to just skip the division part, if it's 1, what are the factors of 3? Plus or minus 1, plus or minus 3. How does this help you when you go to step 2? How does this help you when you're looking at the graph? What are our potential x-intercepts? 1 or negative 1, 3 or negative 3. So then when you're looking at the graph, you're specifically seeking out that value. Okay, it has to be one of these 4. Okay? All right, so graph it.
Yeah, because I couldn't see the 2 graphs like by themselves.
So then see how we got -30?
Yeah.
So the minimum has to be lower. Did you mean positive 30?
I think so.
Okay. There you go.
Okay, thank you.
All right, what did you guys' graph tell you? What's our x-intercept? Yeah, positive 3, right? So You can see it goes over the 1, 2, 3 here, and then you could also verify that with your table. Have you guys noticed anything about when you have 2 x-intercepts versus when you have 1? Because in the last one we had 2, this one we had 1. Is there any pattern that you guys notice about when that happens? Yeah, that's not the pattern. When does it happen? Let's see, let's look at our part A. So part A, right, this is our polynomial. How many x-intercepts do we have? 2. This one we had 2. This one we had 1. What's the difference? Yeah, the degree, right? The degree of this is 3. The degree of the other ones was 4. And if you think about this, when you're doing synthetic division, you're dividing. This is dividing by a factor, right? So if it's 0, it's like x minus 0. So really, you're dividing by an x term. If you divide x to the 4th by an x, it drops down to what? You divide x to the 4th by an x, it drops down to x to the 3rd. If you divide x to the 3rd by x, it drops down to a x squared. So it's a quadratic, right? And then once you have a quadratic, you can solve it. So you only are going to have to do synthetic division 1 time here, because x cubed divided by an x is going to be x squared, which is a quadratic. So once we do this, we're going to be able to use the quadratic formula. So we have the number, the x squared. How did this go? Did you guys get x squared plus x plus 1 equals 0? Okay, did we do the quadratic formula? This is pretty nice because everything's going to equal 1 when you plug it in. Okay, so x equals the opposite of b plus or minus b squared, which is 1, minus 4ac divided by 2a. Okay, so I have 1 plus or minus. I can see this is going to be 4. 1 minus 4 is negative 3 divided by 2. So to get the negative out of there, I have to insert what? The I. Now I can't simplify root 3. So I'm going to divide these both by 2. And then when you are simplifying, you do want to keep these in a plus bi form. So you can think of it as negative 1/2 plus or minus root 3 over 2i. Okay, I would not mark it wrong if you kept the I there. I just try to be consistent with the form and what you might see on your answer key when you're checking your homework. So your zeros, there should be 3 of them, are 3, negative 1/2 plus root 3 over 2i, and negative 1/2 minus root 3 over 2i. Okay, so you do have a total of 3 zeros, which again is something I usually do at the beginning. Like I tell myself, okay, I'm trying to find 3. Alright, so when you're doing these, make sure that all of your roots are reduced to your simplest form, which means if there's a perfect square under the radical, reduce your fractions. Okay, if there's negatives under the radical, and then a plus bi form, if you have an imaginary complex answer, and then your exact values, so no decimals. So you're going to keep them as your roots, okay? All right, and then we are going to finish through 6. So that was the start of through 6.